EarthCube. Go ahead, Joe.
Thank you. Thank you very much. It is a pleasure and an honor to be here. And what I'd like to do is take you on a little bit of a journey with our EarthCube data to set the stage in this room and more generally with respect to big data and metadata in particular. There's sort of three conversations going on. There's a nuts and bolts conversation, which is important, that some of the things that Mark talked about in terms of distributed users, some of the things that Gerhard talked about sort of more organic mechanisms, the nuts and bolts of how systems work matters, details matter. But there's a second conversation, which is about the actual science itself and the impacts and the grand challenges that motivate this. What I'm going to focus on is the third conversation, which is the institutional context within which this takes place. And how do we think about aligning the institutions? And perhaps a way to describe this is that the nuts and bolts is a conversation about how structure drives behavior and structure matters. The institutional conversation, to take an adage from industry, is that culture eats strategy for breakfast. And so we're going to talk about some of those cultural issues. We've done work on stakeholder alignment with respect to energy, transportation, the natural environment, the cyber infrastructure, various domains. I would argue that in all of these domains and in so many others, the inherited institutions from the 20th century do not match on to the work that is needed for these systems. Institutionally, there are two requirements that we ask of these institutions. One is that they help to create value, and two, that they mitigate harm. And I would argue that the inherited institutions are incomplete in how they do either one of those. Not only that, but the pace of technological change is accelerating. This is an image from the 1950s, of course, of the babysitter of the future, and we all know how it really turned out. And I put this here not just for the humor, but because the pace of change will change our assumptions. In the world of metadata, at least on the search side, search technology takes whole parts of metadata that were very structural and sort of sets them aside as people use semantic tools and methods. And so the pace of technological change is not only a constant on the technical side, but I would argue that the institutions themselves are now changing at a much faster pace, corresponding to the accelerating pace of technological change. So with that as a context, EarthCube. EarthCube was designed initially in response to a vision that was motivated by the view that the Earth can be seen as a system in which carbon moves from the air to the water to the land in ways that are crossing disciplinary boundaries and of profound importance for life on the planet. What I've done is I've taken some of our data on EarthCube and organized it with respect to the 5 questions that have motivated this session. And for the first question, I'd actually like to focus on this idea of going across domains and silos. When we began our study of EarthCube, we came up with a set of categories for the fields and disciplines for which data sharing was needed. This is the list. And in fact, when you do any kind of stakeholder assessment, you have to first begin by specifying who are your stakeholders. And I would argue in any of your initiatives, there are probably 30, 40, or 50 categories or types of stakeholders that are relevant, with many folks populating those. And figuring out the right granularity to specify stakeholders matters. I will also say that these categories are only partially complete. One of the important things about the EarthCube story is they did a series of roadmaps and nuts and bolts kinds of activities and discovered that there were key stakeholders not in the room. And so starting last fall, there's a series of domain workshops that they've launched to get the voice of the customer in fields and disciplines. The ones that have been held are listed here, and there's another 10 or more scheduled. And the important thing about that is twofold. First, the customers come forward in categories that don't exactly match the map that we developed. So you have to understand the sort of emergent organic nature of who are your stakeholders. But secondly, by reaching out and hearing the voice of the customer, that was a pivot in the development of EarthCube that was critical, and I'll say more about that later. I also want to say that when we ask people, well, what's your actual area of expertise? We have about 1,200 responses to our stakeholder survey. We have about 700 unique responses along these lines. So that in terms of the actual sharing of data tools and models within specialty areas, it's a very fine-grained, unique process, and the metadata questions are in some ways scalable. By the way, I do know the person who said it's complicated, and the answer is, in his case, it is. But at any rate, here's what I want to share with you. Actually, with NSF funding before the EarthCube study, we set out to do a way to visually represent the alignment or misalignment of stakeholders in complex systems. We developed something called a Z-flower, which I'm about to share with you. But if you just ask people a question, for example, how important is it for you to find data tools, models, and visualization tools within your field, on a scale from 0 to 1, you get responses with means of 0.8, 0.9, 0.6 in terms of the responses from the data centers, from the folks at the EarthCube website, or the folks at an early career workshop. The visualization that we've created basically looks like this. Each stakeholder is assigned a hexagon, so you can uniquely see every stakeholder's point of view. We tile them from the middle out, so the mean is in the middle. The ones closest to the mean are in the middle of each Z-flower. The outside are the outliers, positive or negative. And so you can literally see the central tendency. What's underneath this is the view that you can conceptualize any complex system, certainly any of the data initiatives that you're involved in, as a matrix with stakeholders on one side and interest on the other. 30 or 40 interests might be at play, 30 or 4 types of stakeholders might be involved. And what we've done here is we've taken one vector of the interests of the different stakeholders on a given item, and we've spiraled them to make the Z-flower. And you can instantly see that there's a handful of folks that say it's not important. Those are the outlier, the red hexagons, to share data tools and models. But the vast majority of folks are saying it is. We then ask them, well, how easy is it? And of course, you can instantly see that people are saying, even within my field, it's not easy. We ask them, well, how important is it to go across fields and disciplines? There are some folks, the red hexagons, that are saying it's not important, but a large number of folks are saying it is. We asked how easy it is, and you instantly see that folks are saying it's even harder to go across fields and disciplines. We asked people, well, what kind of data are you using? And of course, this is just our top 25 list, and the tail goes out considerably when we get into the dark data that's held by individual investigators, particularly among geologists and others. But you can see that there's a wide range of data types that are involved, and so you all know better than I just how complicated the metadata issues are across data types. We did ask people, is it important to specify guidelines for interoperability and uniformity? And I have to say, the NSF was very cautious about our even putting this question in the survey because they didn't want to be seen as setting standards. Yet the response is yes, people say it's important to do so. And by the way, that culture eating strategy for breakfast for the NSF and for many agencies that are used to viewing the researchers in science on a competitive model to instead be in the model of doing institution building is a culture change for the agency. We asked, by the way, how adequate is the current range of tools that exist, and of course, there are some bright spots, some folks that are saying actually it's working, but the majority of folks say no, it's not, so there's a gap. So that just begins to get at how do we think of who are the domains within which we're going to ask these questions. The second question, and I just have a single slide on this, is you asked how do you incentivize researchers to engage in this process. And I'm actually going to go back in the social sciences 50 years to a fellow named Kurt Lewin. He argued that with any change, you can look at driving and restraining forces. And in this case, there's a number, this is just a handful of them from the qualitative data, a number of driving forces that would argue for interdisciplinary innovation in the geosciences, the urgency of the issues, the importance of the questions, the positive signals from funding agencies, the universities emphasizing cross-disciplinary work, colleagues who are open to collaboration. But there are also barriers. There are the technical nuts and bolts issues around interoperability. There are career development issues. When we did the early career workshop, one of the researchers stood up, and it was kind of like an AA meeting. She said, "I just realized I am a data hoarder." But she said, "I'm a third-year assistant professor. I just finished a project. Should I take another month or so to set my data up so that it can be shared, or should I move on to the next project to complete my journey towards tenure?" Those are significant and important issues. And then there's the issues of publication, and we're actually making our data publicly available. And in an article in which we announced the sharing of our data, we're going to argue that, in fact, right now, the venues for data sharing, for knowledge dissemination, which are basically journals and conferences, may in the future be joined by data sets themselves that have attached articles with them, and that you go to the data set to find the knowledge rather than relying on the data to go to the journals. And so the institutions themselves may be realigning as we talk, and that's in a sense what's on the table. But the key point that Kurt Lewin had is that when it comes to systems change, the power is not in pushing harder on the drivers. The power is in lowering the barriers. That the drivers have a lot of intrinsic properties that will drive themselves. And so when you ask what are the incentives, I would say incentives are important, but more important is systematically understanding the barriers. One of the interesting things is if you remove a barrier, you typically create a driver. So if one of the barriers is lack of credit for sharing data, and you create DOIs that are attached to the data so you get a sharing count for reuse, you've actually created a driver. Your third question is, how do we challenge developers to develop analytics in a coherent way? I'm just going to share a little bit from the EarthCube data. We asked people, how good are geoscientists in sharing data, software, and tools? And the mean on a scale from 0 to 1 is a 0.45. You can see that there are some bright spots, but the majority of folks are saying not so good. We then said, well, how good are the cyber community in sharing data and software? And the response is almost identical, not so good. We asked, well, how good is geo and cyber at working together? And the answer is really not so good. So we have some cultural issues that regardless of how you set your metadata, if you don't engage these cross-cultural conversations, you're not going to succeed. By the way, we asked how good is end-user training on tools and methods, and the answer is worse still. That's a mean of 0.3 on a scale from 0 to 1. The fourth question you ask is, well, what about data ownership and personal identification issues? We did ask people, are there unresolved issues with data held in the federal government, data held by individual investigators, or issues of attribution? This is the data across all the different domain workshops, and you can see remarkable consistency across fields and disciplines in saying that there are big unresolved issues in these domains. So again, it just sets the stage to really motivate the work that you're all doing. We also asked people, well, what are the barriers to sharing data? We kind of constructed our top 10 list from the qualitative data. Some of these are technical, issues of standards of repositories and file size and so on. And by the way, when geoscientists say the file size is too large, you're talking about terabytes of data coming off satellites and so on. But there are also social system issues here around credit, around time, around resources, and not wanting to be scooped and so on. Lastly, you asked what would be the 2 problems that you would like to solve. And I actually think that there's problems 1, 2, 3, 4, and 5, which are all about forging robust and agile institutional context for data. This just shows some of the twists and turns, pivots that EarthCube has taken in its first couple of years, or year and a half really. And during Q&A, if you want to go into each of these, we can do so. And there's other people in the room here who have lived these twists and turns as well. But I just want to highlight, as I said earlier, this notion that there was quite a bit of work to figure out how to get our arms around the nuts and bolts of EarthCube, and they realized that they were at risk of what we call build it but no one comes. And so the shift to really understand deeply the voice of the customer with the domain workshops is a pivot that I think was critical. They're now moving towards investing in the building blocks and having this federated system, but it's informed in that way. And I think any data initiative will need to work along those lines. The last thing that I want to share with you by way of a framework is that you can imagine that there are situations with either a few or many stakeholders, and most of you are in situations such as the upper left-hand corner where there are already scattered existing instantiations that involve the reuse and sharing of data in various forms and methods. The new initiatives that are meant to bridge across these are generally going to be superficial initially. Over time, you'll get more intentional, deep dive, selective efforts, and the real goal is to have the clear, coherent vision and alignment of interest with many stakeholders, allowing you to bridge across large domains. So to finish up, I'd like to quote Ralph Cicerone, the president of the National Academies of Science, who points out that we face substantial challenges, many of them human in source in terms of the impacts on the planet. He says the scales and complexities are unprecedented, the solutions will have to be iterative, and he argues that in fact individuals alone will not be able to do this. It will really involve rethinking the institutions themselves in order to leverage and address the challenges that we face. In fact, I'll just go into one item in my appendix to motivate this even further. The National Academy of Engineering has identified the most important challenges of the 21st century. I would argue that each of these challenges involves big data in fundamental ways. And I would also argue that each of these challenges has inherited institutional arrangements in which we have work to do.